Hello, this is day 10 of chapter 12, and this is kind of a review of most of the things that we've covered. So we have some formulas about the sequences. There's an arithmetic sequence formula, an arithmetic series, geometric sequence, geometric series, and an infinite series sequence. And the infinite series is presuppose that it is a geometric with R value being less than 1, or between 0 and 1. So find the sum of the first 20 terms of this situation. So in order to do this, we need to know what type of situation we have. One, it's a sum, so we're looking for a series. The first 20 terms, that's helpful. We know that n is going to be 20. And then we kind of need to know some other things. This is a sub 1. That's nice. And we can tell by looking at it that it's not arithmetic because it's not going up by an even amount each time. And so we could try and test to see if it's geometric, find an R value, 18 divided by -6, or you could do -6 divided by 2. Either way, we're going to get -3 as our R. So this is a geometric series. It's geometric because we have an R value, and it's a series because we're adding them all up. So geometric series formula. S sub 20 is a sub 1, parentheses 1 minus -3 to the 20th over 1 minus -3. And I would suggest putting this into a calculator and using parentheses around the -3. So this would look like 2 parentheses 1 minus -3 raised to the 20th divided by 1 minus -3. And I get a very large number. I'll take a moment to make sure I put that in right. First term, 1 minus r to the n, 1 minus r. Okay. This ends up being -1.7433922 times 10 to the 9th. So there's actually, the decimal point should be moved 9 places to the right. That's scientific notation. So I'm just going to copy this so I don't mess it up. Interesting. Okay, so it's basically -1.7433922 1, 2, 3, 4. That number. -1,743,392,200. Wow. Okay. How many pieces of wood can be cut from a tree that is 465 inches tall if the first piece is 3 inches long? So let's just pause for a second. Like, I don't really know where this problem's going yet because I'm just reading it for the first time. But I know that the first piece is 3 inches long. I mean, that's the beginning of a sequence. That's that. So even though I don't know what's happening, I know some piece of information already. Each successive piece is 4 inches longer than the previous. That sounds like each next piece is being added by 4, so that gives me a common difference of 4. That's D. And the question then is, how many pieces of wood can be cut from a tree that is 465 inches tall? So if I added up all of these pieces together, it would have to be 465. That's how tall it is. So essentially, I want to know how many pieces of wood. So in sum, we know that S sub n, the total, is 465. I don't know what n is. N is how many pieces, how many terms of this sequence, how many, additions of, how many starting at 3 additions of 4 there are to make up 465. All right. So we could use the formula. We're looking for n. And we don't really know what the last piece is, and we do know D. So I would use this formula. S sub n is equal to n over 2, 2 times a sub 1 plus d n minus 1, and just see where we are. So this is 465 equals n over 2, 2 times 3 plus 4 times n minus 1. And we can go through some simplification here. This is going to be 6. You could distribute this. This would be 4n minus 4. And so we have 6 plus 4n minus 4, all in parentheses. I could combine these two guys, 6 and negative 4. And I would have 4n plus 2 at that point, 6 and 4, negative 4. And then I would also, I now have this over here that could be distributed. So this would be half of 4. N's are going to get squared, and then 1/2 times 4 is 2. N squared plus just n, 1n, 2 times 1/2, and then n. All right, so that was all just some basic simplification, just kind of organizing things. But we have a quadratic. We have 2n squared plus n. So I'm going to subtract 465 to both sides. So it can be 0 on this side. And now we can solve the quadratic. Offhand, I'm not going to try and factor that. I don't want to use quadratic formula necessarily, though I could. I'm just going to plug that into Desmos and just see where my zeros are. See which ones make sense. 2n squared plus n. Minus 465. And I should be using x for this one's probably. And there we are. We see that this is going to be some parabola. You could zoom way out to see it if you needed to. But we just need to know where it crosses the x-axis. 15. And you can go down here. It's a negative 15.5. But we can't have a negative amount of terms of a sequence, because the terms are just counting up incrementally one by one. 15 would be our answer for n then. So it would take 15 pieces of wood, starting at a 3-inch piece, and then you're adding 4 inches longer for each successive piece. You add up 15 of those pieces, you would get up to 465. Okay. Find the sum of this geometric series, or state that the sum does not exist, and explain your reasoning. All right. First of all, we want to confirm that this is geometric, because we would need to find r either way. So it would be 15 divided by 25, or 9 divided by 15, and we should get. We take out a 5 would be 3/5. Take out a 3 would be 3/5. So 3/5 is our r value. And basically, we know that this sum will exist because the terms are getting smaller. So we're not going to just keep on adding on increasingly large terms forever, because our total would just get increasingly large. But if we're adding on terms that are smaller, as it gets successively smaller, then our sum will increase, but it will increase by smaller and smaller amounts, giving us a limit, essentially. So S sub infinity is a sub 1, 25, over 1 minus 3/5. And so I'll just kind of do this by hand, I guess. 2/5. So we would have 5 times 25 is 125 over 2, which is 62.5. So that is the sum of all of those terms if you added up an infinite amount of terms. This next one, I can see that r be 5 over 2, or 12.5 over 5. So it's going to be 2.5. Now, because r is 2.5, that means each next term is going to be bigger than the previous. So if you added up an infinite number of terms, your sum would just increase without bound. So you could say that this the sum does not exist because our terms, r is greater than 1 basically, and and because of that it increases without bound. All right. A ball is dropped from a height of 18 feet. It bounces 90% of its previous height. How high does it bounce on the fourth bounce? Okay. I find this problem a little tricky, and so I'm going to do this problem. I'm going to work this problem the way that I interpret it. And you can have a debate about it with me later if you'd like. A ball is dropped from a height of 18 feet. I'm not going to say that that is a sub 1 because here's the formula. A sub n, if 18 is a sub 1 and then r is 90%, okay, then this is n minus 1. Okay, so this means that if a sub 1 is 18, I could plug in 1 for n and get 0.9, and this would be 0. 0.9 to the 0 is 1, so a sub 1 is 18. All right, so that formula, if it's set up that way, but what this means is that a sub 1, if I want like a sub 4 to be my fourth bounce, then a sub 1 isn't a bounce, it's the height it dropped from. So you have 18 feet, it drops, and then it bounces up to here. Okay, so this would be your bounce. And then this is your next bounce, second bounce, third bounce, fourth bounce. So how high does it bounce on the fourth bounce? This is what I'd be looking for. And if that's the case, then a sub 1 shouldn't be 18. A sub 1 should be how high it goes after its 90% is applied once. So that's kind of the way I'm viewing this problem. So all that means there really is that I'll find 18, and so times 0.9, this will be the first bounce. And it is 16.2. So that's a little confusing, and you kind of have to wrap your mind around what it's asking. It's dropped from a height. It didn't bounce. It didn't have a first bounce to a height of 18 feet. All right. You could also just figure out what on the fourth bounce would be the fifth height. So you could find a sub 5 in this situation and still use 18 as your starting amount. But I tried to view it this way. So 16.2 times 0.9 to the 4 minus 1 power. And you would get 11.8. Okay, and I'll do it in red here. So if we're talking about how high does it bounce on the fourth bounce, that means that if the fourth bounce is the fifth height, so we would say because the first height is 18 and it hasn't bounced yet, so then first bounce is the second height, third height, fourth height, fifth height. So we want to know how high after the fourth bounce is the fifth height. So you would say a sub 5 equals 18 times 0.9 to the 5 minus 1. And you would still end up with 11.8. All right, so those two ways of thinking about it. Find the sum of the first 25 terms in this arithmetic series. Okay, first 25 terms. Sum. N is 25. And then we know the sum is the series and it's arithmetic, so we could figure out the 25th term, whatever that is. But I can easily see what the common difference is, so I would prefer to use the second formula that we learned. All right, so S sub 25 is N 25 over 2 parentheses 2 times A sub 1, negative 34. D looks like it's positive 6, so plus 6. N minus 1 is 25 minus 1. And then this we can just put into Desmos, just a calculator. 25 divided by 2. 2 times n minus 1 is negative 34. And then plus 6. 6 parentheses n minus 125 minus 1 parentheses. All right, Desmos should be all right there. You get positive 875. All right. And a last example, write a sequence that has 5 geometric means between 8 and 91.125. That means we have a sequence with 5 terms of a sequence between these two numbers. Okay. All right, and I see that I made a mistake there. This should be an 8. And there was 5 terms there. All right. So I want to say that this is, we know some things. This is a sub 1. This is a sub 7. If you count it up, that's the 7th term. And if I knew what R was, I could just use R. 8 times R would be this term. 10 times R would be that term, and so on. But I don't have R. We got to find it. So I have a sub n. I could have the formula, but I know that n is 7. If n is 7, I know what that term is. So it would look like this. 8 times R to the 7 minus 1. But we can do one better, is that 8 sub 7 is actually 91.125. Okay, we know that 7 minus 1 is 6, so that's the exponent. We should divide by 8, though, to start. So 91.125 divided by 8 is 11.390625. Or, I'm going to keep it as a fraction just for fun. I just hit that little fraction button there on the left. 729 over 64 equals r to the 6th. And then I could 6th root both sides. However, it's harder to find that on a calculator. We could just raise it to the 1/6 power. That would achieve the same goal of getting r by itself, because it would be r to the 1st power from the power to power property where you multiply. So 729 over 64 to the 1/6. Whoop. Divided by 4, and then raise this to the 1/6 power. And it's 1.5. Cool. Probably didn't need to change it to a fraction. But if it's 1.5, now I can start filling in what these terms are. So 8 times 1.5 is 12. Times 1.5 is 18. Times 1.5, 27. Times 1.5, 40.5. Times 1.5, 60.75. Times 1.5, 91.125. So we should end right there, and we did. All right, I hope this helped as a review. Good luck.